Right, so now we're going to sort of start heading down the pathway of optimisation. It's a pretty big unit, pretty big component of what you'll be doing between now and the end of the year. It's really important that you get your head around the idea, but I think it's a really good thing for you guys that this is going to be such a heavily used topic, because it really relies on the same sort of skills that you've been using already. Previously, we've dealt with a heap of max and min problems, all right? And we know that with maximum minimums, we're looking for a point when the derivative function f dash x equals 0, or in some scenarios, we're looking for points where our domain cuts off. So that's like the edges of our function, because obviously if it's not turning, it's going to be at the edge of our function. So we have to check our domains, so the size of our function, and where f dash x equals 0. Now, there are three really common things, I guess, or three common ways that these questions get asked in senior mathematics, and it's probably good to get your head around the idea to introduce these three topics and get your head around the idea of what they are and how they'll appear. Okay, so I'm just going to square that up. So the first type, and it's the type we've dealt with pretty much conclusively, it's the only one we've dealt with really so far, and that's abstract. And that's just where we give you a function, we say, y equals this, or fx equals this, solve, or some function, find the max or the min inside a domain. Now there is no real world application, it's just a whole bunch of numbers. You derive, sub in 0, solve for x, check your domains. That's how you go about that. I will go through that example in a second on the board, but that's an abstract example, and that's the one that you're really familiar with today. The next one, and the one where we're heading down, and this is where we talk about optimisation, obviously trying to get the best scenario, which is what optimisation is all about, getting the most out of a scenario, is when we've got geometric style of problems. And this is a geometric style of problem here. Geometric is just talking about shapes, so volume, area, surface area, that sort of stuff. And you will need to be really familiar with the types of shapes, the area equations for squares, rectangles, circles, prisms. You'll need to be familiar with the volume equations, you'll need to be familiar with perimeter equations, all sorts of things like that. You'll get your head around that idea as it goes further through the term, but that's all about area, volume, perimeter. Those sorts of problems are trying to get the max or the min. Usually it's a maximum, but the maximum out of that scenario. So in this scenario here, we've got a person who owns a property, they've got 60 metres of fence, and they want to find the max area. Now normally if we were just given a four-sided shape, that'd be easy, it'd just be a square with 15 metre size. However, with this river here, we only need to fence 3 sides. So a lot of these problems are about framing the problem up, creating an equation, then deriving it, exactly the same thing. Deriving it, finding our point when derivative equals 0, checking our domains to make sure that we have got a maximum or a minimum. Cool. And the last one is one that we'll get on board with. It's pretty similar to the abstract sort of thing. There's a little bit of creation equation, but it's usually dealing with things rate, so things changing over time. In a real world scenario, you've generally got to create an equation or a profit equation. It's usually to do with money or time, and you'll create an equation, derive that, let that equal 0, and find out when you've got a max or a min. Okay, an example of this would be a company produces some number of litres, X litres of juice per minute. This costs them $2 per minute and $1 per litre. The revenue is 6 times the square root of x. What determine the maximum profit? Okay, so we'd have to obviously create a profit function, derive that profit function, let that equal 0, solve for x, and then find out what our max profit is. So what amount of juice they should be producing. Okay, I think the best way to go through this is to go through some examples. I will go through each of those in a following video. I won't do them now so it doesn't get too long, but I'm going to go through and solve my abstract, solve my geometric, and solve my rates, so you guys can get your head around the idea of how they're different.